Hi everyone, welcome back. In this lecture, we are going to understand a critical component that keeps microservices responsive and stable even when traffic suddenly spikes or when one of your services begins to slow down. We are talking about the load balancer. So, what is a load balancer? A load balancer is a smart traffic manager that sits between your calling service and multiple running copies of the target service. Its job is straightforward: distribute requests efficiently so no single instance gets overloaded. Think of it like a restaurant host. Customers come in, there are several empty tables. The host decides where to seat each customer to keep the restaurant running smoothly. The load balancer does the exact same thing but with microservice instances. Let's walk through the diagram you are seeing now. On the left, you have the employee service running on port 8080. This service needs to call another service to fetch employee-related address information. But instead of calling a single address service, notice what's on the right side of the diagram. Two separate running copies of the address service. One is address service 1 running on port 8081. Another is address service 2 running on port 8082. These are two instances of the same service. So what is a service instance here? An instance is simply one running copy of your microservice. If you start the address service once, you get one instance. If you run it twice, maybe on a different server or a different port, you now have two instances. Both do the same job. Both handle the same endpoints, but they share the load together. That's exactly what your diagram shows. Two servers, each hosting one address service instance. Now the question is, why do we need multiple instances? A single address service instance cannot handle thousands of concurrent requests. It will eventually slow down, time out, or even crash. So instead of overloading one server, you run multiple instances of the same service to spread the traffic. But this introduces a new problem. How does the employee service decide whether to call port 8081 or 8082? This is where the load balancer becomes essential. Now let's see how the load balancer works. Look at the center of your diagram. The load balancer sits between the employee service and the two address service instances. When the employee service makes a request, it doesn't pick an instance. It doesn't know which one is healthy or which one is busy. All requests are sent to the load balancer. The load balancer then decides, should this request go to address service 1 on port 8081 or address service 2 on port 8082. It makes this decision intelligently. It checks which instance is currently free, which one is responding faster, and which one is healthy. This way, traffic never piles onto a single instance while the other sits idle. Now let's see how load balancer handles failures smoothly. One of the biggest advantages of a load balancer is how it handles failures. If address service 1 on port 8081 goes down, maybe the server crashes or memory becomes full. The load balancer simply removes it from rotation. All traffic is now routed cleanly to address service 2 without the calling service ever knowing something went wrong. This is what makes microservices extremely resilient in production. So to summarize the entire diagram, the employee service calls the load balancer distributes requests between address service 1 and address service 2, and the system remains fast, stable, and scalable even under high load. The load balancer keeps your microservices healthy, responsive, and fault-tolerant by spreading traffic, detecting failures, and managing multiple service instances intelligently. And that is the complete working explanation of the role of a load balancer in microservices.